Hi, my name is Alex Borde, and in this video I want to introduce you to the concept of just-in-time server provisioning. So this is a hardware allocation strategy that has the potential of giving you up to 30% better resource utilization by just changing the way you consume the physical, bare metal layer. Right? And in many organizations, what happens is that there's a lot of waste, and this is not because the hardware itself is wasteful, but because it takes so long to actually productize hardware, right? So if you want to build if you need a new VCF cluster, what you do is you size it, and you order it, then you wait, then you rack it and stack it, then you install the software, and then finally, sometimes 3 to 6 months later, you actually can put workloads in there on the respective rack, right? So this is a traditional approach, and migration across using vMotion or something similar for containers does not mitigate this, because many organizations, these clusters are isolated from each other, so the workloads not really actually move, right? So in contrast, just-in-time server provisioning, what that does is that you apply essentially what hyperscalers do in their own data centers, right? But you apply it in your data center. So first, you standardize on some configurations. So you have something like, okay, small, medium, large, or configurations, right? And then when a particular workload is needed, so let's say a VCF cluster is needed, instead of ordering and then waiting, you just take from the pool of servers that you have available, and you provision only the respective servers that you need, right? So, and the system, because any server can become any workload, will allocate you some servers from the pool that match the characteristics that you need. So let's say you get this server and this server for your VCF1 cluster, right? And you don't get the third one, because that may, if you don't need it, you don't get it. You just leave it as it is. And then only when you actually need it, then you get another one, right? In the meantime, other parts of the organization can consume, and you can have a Kubernetes cluster composed out of these servers, maybe an AI server here, and so forth. So they go into the pool, they come back into, they go out of the pool, they go back into the pool, dynamically based on what's needed, right? So, and if you need to expand the cluster, you just add a new server, right? And so obviously key to this is dynamic network allocation, and a software that is able to do this, like MetalSoft. But what you get is this cloud-like access to the resources. Right, so that's about 90% faster or 99% faster in certain cases than what you have today. And also you get that 30% better overall utilization, right? So this comes from the fact that you don't overorder, you don't underorder, and you just utilize your hardware much better. Thank you for watching.